Okay, homework 1.2, day 2, starting with number 93. It asks us to graph this function if up here, if f is our original, graph the transform function g. And we're going to make a note, we're always going to work inside, out. So you want to start on the inside and work your way out. So the first thing that was done to x, first thing is that we changed inside the function, and so we replaced x with x minus 1. So if we go from here to here, this moves it right 1, and then if we go from here to here, this moves it up 2. So we're going to go right 1 and up 2 for every point. So for this point, we're going to go right 1 and up 2. For this one, I'm going to go right 1 and up 2. For this one, I'm going to go right 1 and up 2. For this point, I'm going to go right 1 and up 2. So that means that my new picture should look like this if I move all the points like so. Again, the main thing to know when you're doing transformation of functions is you always want to work from the inside of the function outward, because sometimes order matters. So just to be careful, that's what we do. So then you look at number 95. It wants you to evaluate the function and then sketch a graph. So evaluate the function and then sketch a graph. So if I evaluate the function f of negative 4, well, since this input is less than 0, that means I put it into this piece, so it goes in here. So f of negative 4 is negative 4 squared minus 3, which is 16 minus 3, or 13. F of 0, since for inputs greater than or equal to 0, we use the bottom piece. This is going to be 4 something minus 3, and the something we plug in is 0, so we get negative 3. And then for the last one, since 2 is greater than 0, we plug into the last piece. So f of 2 is 4, plug in 2 minus 3, so it's 8 minus 3, or 5. Now if I was going to graph that thing, I know that we have a line right here at x is equal to 0, where to the left, I'm going to draw x squared minus 3. So now that x squared minus 3 just looks like the graph x squared, but it is down here, pushed down 3 units. 1, 2, 3. Yes, there's a hole there. But then, now I'm going to graph this, and that's just a line where when you plug in 0, you get 3. So that means it's actually going to be filled in here. And it's going to go, we notice that the slope is 4 over 1, so that's our rise over run. So every time you run 1, you're going to go up 1, 2, 3, 4. So that's what it's going to look like. So when you put in 1, that is the point 1, 1. This is the point negative 3, I'm sorry, 0, negative 3. And then to put another point over here, if you put in negative 1, f of negative 1, or I guess we've already got one, I'll just use the point that we have. So f of, I could have just used the points that they gave me. Could have just used the points that they gave me. So what if I use this point that I already found over here, f of negative 4, over here at negative 4, I know that I'm going to be all the way up here at 13. So I've graphed 2 points on the thing on the left, 2 points on the piece on the right, and I'm done. Notice how they really did set me up nicely. I could have just used these points to graph the entire thing, and that was pretty nice. Okay, 103, a company purchased some computer equipment for this much. At the end of a 3-year period, the value has decreased linearly to this much. Okay, So I'm going to have my value as a function of time is what they want. So it was originally 20,500, and at the end of a 3-year period, they say it decreases linearly. So I know it's going to be a line. And so I'm just going to write down that this is mx plus b. But we know that b is just our y-intercept. That's the same thing as an initial value. So this is my initial value. And instead of x, we have t. So this is mt plus b. So we're going to have some slope t plus an initial value of 20,500. And now there's my equation. I start off with this much, and I add to it this every time. We know that's going to end up being a negative b. And so what's one number that I know? I know that after 3 years I get this much. T is in years. So if I plug in 3, I get out 12,300. I'm going to have 20,500. Now there's an equation that I can solve for for m, excuse me. So when I subtract, I end up taking 12,300 minus 20,500. Get what? Negative 8,200 is equal to 3m. So if I take that and divide by 3, I end up getting that m is equal to negative 8,200 divided by 3, and it works out not nicely. Excuse me, where m is approximately equal to negative 2733.3. So I could say it's approximately that much, right? But I would probably, to be exact, keep this value for m. So v of t is equal to negative 8,200 over 3 t plus 250. Oh, did I get that right? No, 500. So that would be my linear equation that they were looking for in part A. Find and interpret the x and y intercepts. So for part B, x and y intercepts, I would say, let me go ahead and move some stuff over. Yes, I will plug up my pen in a little bit. Do this. I'm going to move. Poop. Well, I'll just erase because you've got all that. So they are wanting to know where. For B, the x-intercept, we know that that's where y equals 0. So I can just set my whole function equal to 0, and I get this over 3t plus 2,500. And I get negative 2,500, negative 8,200 over 3t. If I multiply both sides by 3, then it should be negative 63,000, but I'm going to make sure. So it's 2,500 times 3. 2,500 times 3. Oh, 6,150. I wasn't thinking, sorry. 6,150 times 3, not 6. 61,500. And it's still negative. It's negative 8,200t. So that means that t is, divide both sides. So divide by 8,200. 8,200 equals 7.5. 7.5 years. Right? And what does that mean in context? So, car or equipment So car is not depreciating, it's equipment. So equipment will be worth $0, because notice we said equal to $0 in 7.5 years. Great work. Let's take this and move it up just a little, okay? Boop. And so what does that mean? Well, now I get to find, if that's my x-intercept, now I get to find my y-intercept, which is where x is equal to 0. But in this case, it's time, so t is equal to 0. Notice what happens. 2,500. You just get 2,500 is your initial value. What equipment is initially worth. So what your equipment is initially worth. So then it wants to know, find the value of the equipment after 5 years in part C. So for part C, I guess I'd plug in 5. So I get negative A200 over 3, plug in a 5, plus 2,500. So I'm going to take negative 8200. I'm going to divide it by 3, and then times 5. Divided by 3 times 5 plus 2,500 is approximately $6,833.33, approximately. That's how much the car is worth, or the equipment. I keep on saying car because this is usually a car depreciation. That's how much the equipment is worth at the end of 5 years. So then D, when will the equipment be worth $3,000? Well, in this case, you simply set your output equal to $3,000 and solve. Plus 2,500. So when you do that, you take 2,500 minus 3,000. That's going to be negative 17,500. Negative 8,200 over 3t. And then solving for t, I take that and multiply it by 3. That gives me negative 52,500 is equal to negative 8,200t. So if I take that and divide by 8,200, I'm going to get the time is approximately 6.4. So in 6.4 years, the value will be $3,000. Approximately. In approximately 6.4 years, the value will be $3,000. And there you go. Let's look at number 5. Family Bakery Cupcakes sells them at an outdoor music festival. There's a fixed cost of $125 to set up the stand. So they want C of X. That's the number of cupcakes. And this is the cost. There's a fixed cost. That's going to be my initial value. That's what we start off with. So we're going to have some MX plus B. Well, my initial costs in this case is going to be $125. So even if I put in 0, I'm still going to have this $125 cost, even if I don't sell any, because I had to make. The owner estimates it is 75 cents for each cupcake. So if they estimate that it's 75 cents, let me resize that. Right. 75 cents per cupcake, then it's 0.75x plus 125. That's our function. Find a linear function. There it is. That is part A. B, the cost to make 160 cakes is C of 160. So it's 0.75, 75 cents for every cupcake plus $125 fixed cost would be 0.75 times 160 plus our 125 is going to end up giving me $245. The owner sells the cupcakes for $1.50 a piece. How many, what? How many cupcakes does she need to sell to start making a profit? Okay. So, sells. So we'll call this our sell function. Our sell function is $1.50 for every cupcake. And what I want to do is I want to find out when does my cost equal how much I'm selling it for. That would be my break even point. When how much it costs to make is how much I'm selling them for. So my cost function over here we said was 0.75x plus 125, and my selling function is $1.50 each, 1.5 each. So I want to know when these are equal. Well, now I have to solve. If I subtract 0.75, I'm going to get 0.75x is equal to 125. So 125 divided by 0.75 means I'm going to have to sell approximately 167 cupcakes to make profit. Actually, it would be equal to, because we break even, so I'll put approximately. We break even at 166.66 repeating. So, be 167, okay, for us. All right, 107, 111, and then we're done. So let's do 107. A car depreciating, told you, classic question. Y is equal to mx plus b because it's linear. V is going to be value over time, so it's actually going to be a v of t is equal to mt plus b. You know that b is our initial value. So if it started off at 26,500 and it depreciates at 5,000 per year, I subtract, 1,500 every year. It looks like that. So that's our linear function. Find and interpret v of 4. V of 4 is this with a 4 plus 26500. Well, if you have two of these, that's going to be 3,000. So 4 is going to be minus 6,000, right? So that means it's going to be 20,500 is value of car after 4 years. Great. It'd be, just so you know, those of you who are going to buy a car, after the first year, it loses 20% of its value. And then after that, every year, it loses approximately 10 to 15% of its value. So just when you drive it off the lot, you lose like 20% of the car's value. They are not the best investments, at least long term. The output as a percent of total capacity of a nuclear power plant is this, where T is time in years and T equals 0 corresponds to 2,000. Predict the approximate percentage output in 2015. So that means 2015 corresponds to T is equal to 15. So P of 15 is equal to 1.8576, plug in 15, plus 68.052 is approximately 1.8576 times 15. So times 15 plus 68.052, 68.052. This times this, I'm making sure all my numbers are right, approximately 95.916. Actually, it's exactly equal to this. Thus, percentage output will be approximately, or I'll just say will be, there's no approximate, it turned out to be equal for us, but maybe the model has approximation. This much at the beginning of 2015. And we're done. Great work, keep it up. Don't forget, you now need to go back and check all your answers.